Hi, good evening, everyone. Good evening. Those who are watching on YouTube, you also join fast. Everyone, join fast. I'll wait for 1 minute and then we'll start. Welcome, everyone. Welcome. Welcome, everyone. Join fast. Welcome to the first lecture of the case study batches. Okay? Everyone, join fast. Those who are watching on YouTube, you too. Hi, good evening. Join fast, everyone. Today we'll be starting with simulation. Okay? Simulation topic. Okay? Basically, it is not simulation, sampling distribution. Okay? We'll be starting with sampling distribution today. Hi, good evening. Everyone join fast. We'll be starting with sampling distribution today. Sampling distribution is a process used in statistical analysis in which predetermined number of observations are taken from a larger population. Very important point. Huh? This question comes in exam. Kindly note the important point over here is predetermined. We first only decide how many samples are to be taken. Number of observations are taken from a larger population. Okay? The methodology used to sample from a larger population depends on the type of analysis being performed. So, what type of analysis means? What is the type of this? Maybe here. So, what type of analysis is required means what type of sampling I am doing. Do I want a gross level? Do I want accurate? It depends on that will give you how the samples are to be taken and how many samples are to be taken. If I want more accurate results, I'll go for lesser samples. If I want less accurate results, I'll go for this lesser samples. And if I want more accurate results, I'll go for more samples. Isn't it? So sampling distribution is what this question is asked on sampling distribution. Kindly note process used in statistical analysis in which predetermined is very important over here. Huh? Look at this. There are two parts in sampling. This is what you have to remember: population and sample. Okay, population and sample. Whatever you do for population, okay, is known as parameter. Whatever mean you find out mode, median, anything that is known as parameter. Whatever you do for sample, that is called as statistic. Mean of the sample, mode of the sample, that is statistic. Okay. So population means collection of all the items, and sample means part of the population. Okay, means what? If this is my total population, let's say I say that we have to find out the average salary of all the people in Delhi. So that is the population. But you can't go and ask everyone what is your salary. In that case, what do you do? You take samples from various corners of Delhi and various strata. So that is known as sample. So we take the sample from various parts and then apply it to the population. Okay. So population collection of all the items. Characteristics are called as parameters, whereas this characteristic is called as statistic. Now, what do you mean by characteristic? This is size. Size is known as capital N in population. Mean is known as mu. This is called as mu. This is spelled as mu. Standard deviation is spelled as psi. PSI is psi. Okay. Here in sample, you have size as small n. Mean is known as x bar. Some books write it small x bar, some books write it big x bar. Standard deviation. So this is known as same psi, but for samples we generally take standard error. Okay. This is a term used in standard error. Of course, deviation is there. Standard error has slight different meaning, but kindly remember for sampling, always use the term standard error. I'll tell you how to use it. Okay. What are bias samples? Suppose the parliament is debating on the women's bill and you are asked your opinion survey. Now, if you are debating on women's bill and all of them are women over there, then obviously that will be biased. Or reverse is also true. If we are debating on women's bill and all of them are men, then also it will be biased, isn't it? So bias sample means whenever you take the sample from one type of category only. Okay, when 95% of the people are of one category, then it's called as biased. Okay. Now look at this. Sampling is of two, three types. Sampling is of two, three types. One is probability sampling. Basically, two main types: probability and non-probability. Okay. Probability and non-probability. What is probability? Probability means everyone has got an equal chance. You will not do any partiality in this, or it is not based on biased or your own biases. So probability means equal chance to everyone. Now, what are the types of probability samplings here? Two of them are asked in exam, definitely. Okay, two of them out of these will be seen in the exam: simple random, systematic, stratified, and cluster. Out of these four, two will be definitely seen in the this exam. Okay, so what is this? Systematic sampling. Okay, simple random first. Simple random means what? Here we take any 10 students. Okay, let's say I'm asking for, let's say, 60 students are there in a class. 60. Out of them, I have to select any 10. Now, simple random means what? I'll close my eyes and select any 10. I'll close my eyes and select any 10. That is simple random. This is one of the, this is the best sampling. This is actually called as sampling. Close your eyes and select any 10. Okay. Second one is systematic. Systematic means what? I'll call, okay, every 10th student or every 6th student, every 5th student, come here. You stand in a row, okay? Everyone stand in the row. I don't know who's there in the row. And then I'll tell every 5th student, come here. Okay? So this is also, again, systematic sampling means it is also giving equal chance only. Why? Because I don't know who's where. But I've told them to stand in the row and every 5th student should come in. So this is systematic. Stratified means what? I'll divide them. Divide them in the sense, what will I tell them? What you do? You stand, you make three groups. One group is of 40 to 50% marks. Second group is of 50 to 60% marks. And third group is of above 60 marks. So I'll make three groups and then I'll call three students from each group. So this is stratified. Stratified means what? I'm creating strata within them. Strata means, what is strata? Strata means steps. Whatever we call as steps, that is actually strata. So what is the important part about stratified? The important part about stratified is within each strata there are similar qualities. Means what? Within each strata there are similar qualities. What does it mean? It means that 40 to 50% students, means those mark students, they will always think similar. Whereas 80 to 90% mark students, they'll think similar. 40 to 50% will always think of passing. And 80 to 90 will always think of scoring, top, right? But this 40 to 50% marks student will not think like 80 to 90% marks students. 40 to 50% will never think of becoming a topper. So this is a point over here. Within each strata, there are similar qualities. Whereas between different strata, there are different qualities. This is very, very, very important parameter. And that's why this is asked in exam. Many times stratified and cluster are asked in exam. Many times. Out of these two, you'll definitely see one of them. Then what is cluster? Cluster means generally relates to region. I am classifying them as per some students of Goa, some of MP, UP, Delhi, Tamil Nadu. So I'm uh, this classifying them as per the region. Generally, cluster is followed for the region. Now, what are the qualities of cluster sampling? Within same cluster, there is huge variety. Now, see here, it's exactly opposite of this stratified. In stratified, what was it? Within same strata, similar qualities. Whereas in cluster, what is the case? Within same cluster, huge variety. Means what? Even in Goa, you will be having the topper 90%. Even in Goa, you will be having 40%. Even in UP, you will be having the same. MP same. Tamil Nadu same. Maharashtra same. So, within same cluster, there is a huge variety. And within different clusters, they may have similar qualities. What does this mean? It means Goa will also have 90% student and UP will also have 90% student. Tamil Nadu will also have 90%. Kashmir will also have. It means what? Within different clusters, they may have similar qualities, isn't it? So this is basically cluster. And kindly remember, two of them will be there in the exam. Two of them will be there in the exam. Everyone is getting this? Type yes in the comment section if you have understood this. Four types of sampling because two of them will be asked in the exam. 2 marks. Okay. So this is probability. Type yes in the comment section if you have understood it. Okay. Second one is purposive. Purposive means what? It is also called as non-probability. See here, probability and non-probability. What is non-probability? Non-probability means very simple. You see all those TV programs. Which one? That singing program, dance, Indian Idol, all these. Okay. What is that? In that you see there are three judges, either three, two, anything, and they make the judgment. They say that no, your आपका डांस बहुत अच्छा था, आंखों में आंसू भरा है. I have seen so much drama in this. मुझे ऐसे लगा कि जैसे मैं कोई क्या भगवान का कुछ ये देख रहा हूँ, ऐसा वैसा, so many things. And that what that that artist cries, that teacher cries. Teacher means that judge cries. My God. So this is purposive or non-judgmental. Sorry, non-probability. Okay. There it is decided by the person sitting over there. Like in your class only, in your bank also. Check in your bank, your own bank. Some of the students, some of your colleagues get favors. Some of your colleagues don't get favors, right? This happens now in every bank. Actually, the one who always works will never get favors, and the one who doesn't work will always get favors because he is free, he or she. He will always speak, go to the manager's cabin, sit over there for 1 hour, discuss ill means those issues which are not important, and that guy will always get favors. And the one who is working very hard, he or she will never have the time to go to the manager or speak to the senior. They are so much busy in their work, so they'll never get the favors. This has happened in your bank also, in your life also. You might be seeing this, isn't it? Because I've seen this in my career. Okay, means when I was working, okay. For your information, everyone, I've worked for 13 years in banking, and that also not our regular banking. Means I worked in retail banking. I've started with my cooperative banking, then HDFC Bank, then Citibank, and then Singapore DBS. I worked in all the departments. Okay, from retail, corporate finance, trade finance, and treasury. All the four departments I have worked in 13 years, and that also at a senior position, not at a lower level. So I know the ins and outs of these bankings, and I know how favors are done. Okay, how the what appraisals are done. Okay, so what all favors are given. Okay, so all of you agree to this? In your bank also, you might be seeing someone who's very favorite of your manager, and that person hardly works. and you all work very hard, and what happens? Nothing. Then you get only scolding. Okay, so that is purposive sampling or non-probability sampling. Okay, in which the judgment is done. Now there are various types of this. We'll come to that. I'll come to this non-probability. Okay. Now simple random, all these things I've explained now. Now we won't go into the details of this. Okay, because we are in the case study batch over here. Now one thing I'll again from exam point of view, what is asked? Sampling with replacement and without replacement. This is also asked many times. Now this is very simple. With replacement means what? I take out some coin from some bag and never replace it. Okay. So suppose if I want two balls, one green, one red, one I take it out and never replace it back. Then other remaining ones, the second ball is taken from the remaining one. So that is without replacement. Okay. With replacement means what? I'll take the ball out, see it, and again put it back. So that is with replacement. So this question is asked without and with replacement. Always remember in without replacement, the overall size, population size will be lower for the second chance. Okay. We use the term infinite population when we are talking about a population that could be enumerated in a reasonable period of time. You always now you'll hear two terms. One is finite population, second is infinite. Finite means what? Which you can count in a given time. That is very important. In the given time. Okay? Means again it's a relative term. Suppose if I give you 5 minutes and tell you to count, let's say 1 lakh students or 1 lakh something, some huge number of students I tell you to count. Although they are countable, but in 5 minutes they are not countable. So infinite means infinite. The difference is this: when we are talking about a population that could be enumerated in a reasonable period of time, time is very important. If I give you 1 year, then you can count that 1 lakh persons. But if I give you 5 minutes, you can count. Thus, we use the theoretical concept of infinite population as an approximation of the large finite population. Right? Large finite means huge population. Systematic sampling, already I have discussed this. Systematic advantage, yeah. Stratified also we have discussed this. Stratified sampling. Okay. Various strata are created. When do we use stratified sampling? Now this question is asked. When do we use stratified sampling? Stratified sampling is appropriate when the population is already divided into groups of different sizes. And we wish to acknowledge this fact. So when the population is already divided into groups of different sizes. So this question is asked. When do we use stratified sampling? When the population is already divided. Remember this name, this word, okay? See this, middle class, upper class, lower class, this is strata, isn't it? The advantages of stratified sampling are that when they are properly designed, they more accurately reflect the characteristic of the population. Means, what do you understand by this? Suppose, remember this, if I want to sell, let's say, an insurance product of the premium is 1 lakh rupees. If I want to sell an insurance product of 1 lakh rupees, premium 1 lakh, should I go to this upper class or middle class or lower class? Now you tell me. Okay. Middle class, upper class and lower class. I want to sell an insurance product of premium minimum 1 lakh rupees per year. Whom should I go to? Middle, upper or lower? You tell me. Everyone in the YouTube also. Those who are watching free on the YouTube, those you guys also. Okay. Yeah, first answer this, then I'll come to the next point. Should I go to middle, upper or lower? 1 lakh premium. Or let's say 2 lakh premium now. Okay. Nowadays 1 lakh is nothing, isn't it? 2 lakh premium. Okay. So it is upper class, right? So I'll go to upper class. What do you mean by this? I have done the stratified. Okay. If I have to sell a insurance premium of 2 lakh rupees per year, whom should I go to? Lower group, upper group or this middle group, right? So it is upper. Okay. So the point over here is, important point over here is I have already created a strata. Okay. Now, those who have joined new, okay, in this batch, for you, I'll be sharing few PDFs, and those who are watching on YouTube, you also, everyone, I'll be sharing a master PDF with you. This master PDF has many important definitions and important points. Roughly almost 50% of the questions, theory ones, theory questions, come from that master PDF. One liners. Many of them come from that master PDF only. Okay. So that's why I'll be sharing this with you. Okay. So those who are watching on YouTube, kindly note, uh, from tomorrow you won't be able to see this class right on YouTube, because today only there's free class. From tomorrow it's a paid version. So join this without fail. Okay. I'll be sharing master PDF. Then I'll be sharing 2 3 important question bank for this formula bank, and I'm having some questions also, question banks. All of the three I'll be sharing with you. So in these remaining, how many days? 9 days, 8 days. So remaining 8 9 days, you can go through this. Okay. Next one. So cluster already we have done in groups or clusters, and then they select the. This is generally related to region. Okay. Hmm. Now, purposive and non-purposive, non-probability. See this. Purposive means basically non-probability. Now we'll be having the types of non-probability. Okay. Purposive sampling, also known as judgmental, selective or subjective sampling, is a form of non-probability sampling in which researcher relies on their own judgment while choosing the members of the population to participate in the survey. So, own judgment. That's what I said. That Indian Idol, okay, researcher on their own judgment, they think whatever they feel right is right. Non-probability sampling is a branch of sample selection that uses non-random ways to select a group of people. So non-random means what? The same logic over here. The judge is a supreme person. Okay. What are the methods in this non-probability now? See this probability, we have seen this. Now non-probability, these are the ones: convenience, consecutive, quota, purposive, and snowball. Out of these, again I am telling you, out of this, you will get a question on snowball sampling and quota or convenience. Yeah, quota or convenience. And this purposive judgmental is generally asked only. So snowball and quota are very important. These two are generally asked. So what is it? Let's see one by one. Snowball sampling. What is snowball? Snowball sampling means, all of you have seen that many of you might be having the friends, right? MLM, MLM, right? That you had many MLM schemes now. You invest in this, then 10,000 you invest, you'll get double, you'll get triple. Then you bring 3 members. Those 3 members will again bring 3 members. Have you seen all that schemes? Have you invested in that? Anyone? And lost money? How many of you have lost money in this MLM? So this MLM scheme is similar to snowball sampling. In snowball sampling, what do we do? Now read the definition first. From there you will understand. In snowball sampling is a non-probability sampling method where units are recruited by other units to form the part of the sample. Other units means I'll first uh, recruit one person as a sample, or I'll take one sample. That sample will further take other samples. So that is basically this snowball sampling. That's why I said MLM. Okay, similar to MLM. Second is convenience sampling. Convenience means what? This is a cheater sampling. Cheater. What do you mean by cheater sampling? Cheater means what? Okay, I have been told. Let's say your boss tells you. Okay, you are sitting at home today. You are on, let's say, doing some survey. Okay, and your boss tells you, what do you do? Contact 10 persons. Okay, in the city. Contact 10 persons. This many of you might have done in your MBAs. Whenever you did your survey, na, that you had that last year, that all projects and project works. At that time, you might have done this. So you require 10 persons to contact. What do? You sit at home and call your brother, sister, friend. Only you see to it that the name is not same. Your surname is not same, isn't it? You all have done this. You see to it that the surname is not same. Your surname. Otherwise, your teacher will catch you. Same thing is done over here. Convenience sampling. Cheater. I'll sit at home and then I've been told survey 50 people. I'll collect 50 people near my house. Okay. So convenience sampling is a non-probability sampling where units are selected for inclusion in the sample because they are easiest for the researcher to access. Easiest, isn't it? So that's why I said cheater sampling. But remember, in exam, if they ask you, you have to understand the concept behind this. Okay. Second is service. Quota sampling. Quota means what? This is a service guy. Means okay type of person. What I mean by this? In non is a non-probability sampling that relies on non-random selection of a predetermined number of proportions. Okay, of units means what? First only I'll decide. I have to do the sample survey of, let's say, India. Okay, complete India. So I'll decide that out of Maharashtra I'll select 100 people. Out of Delhi I'll select 20 people. UP I'll select 100. Tamil Nadu I'll select some 50. Kashmir I'll select 20. Something like this. So quota means what? Quota is given to each one. Okay. So that relies on non-random selection of predetermined number of proportion of units. Okay. Consecutive guy is a sincere guy. See this. Earlier guy was cheater. Convenience was a cheater. So consecutive is a sincere guy. What does this person do? It's very similar to convenience samplings here. Similar to convenience, except it seeks to include all accessible subjects as a part of the sample. All accessible. So what does it mean? Suppose if I am told to select 50 persons as a survey, as a samples, so I'll go to entire city, sincere person. I'll select 50 persons from various corners of the city. Okay. So this is consecutive sampling, isn't it? And further, top one is convenience sampling, right? So this is how this sampling methods are this defined. Okay. So in exam again, I'm telling you, snowball will be the question for you, and I think so quota sampling will be the question from you for you. Okay, snowball and quota. Okay, convenience is simple, consecutive is simple. These two are simple. These two are difficult. Quota and snowball. So these two will be the questions. Okay. Now let's solve some numericals. Huh? Now we are coming to the technical part. Earlier, here this theory was also important because after all you have to gain marks. You can gain marks from the theory or you can gain marks from the numericals. After all, 50 is your target minimum, isn't it? So this is definition. Now let's move on to mean, mode, median, and range. What is mean? What is median? What is mode? What is range? Now understand this. Mean means what? Mean means the average of all. Okay. Now average of all means what? If I have 50 things to be done, 50 elements, then I'll add them and divide them. So that is mean. What is median? Median means here, understand this, everyone pay attention. Median means I'll arrange all the numbers in a serial order. Now it can be ascending or descending, both. I'll arrange all the numbers in the serial order, ascending or descending. And then I'll find out the central number. Okay. Then I'll find out the central number. For example, let me give you this example. See this. Suppose if I give you the numbers, let's say 1, 2, 3, 4. Okay, 4 numbers are given to you. Okay, let me give you some easy task first. Suppose if I give you these numbers 2, 2, 3, 3, 3, 7, 7. These are the numbers given. Now they'll be given in random ways. Means it will be like this 7, 2, 3, 1, 7, 1, something 7, 2, like this. Mixture will be given. So you have to first arrange them in serial order. Either you can arrange them in ascending or you can arrange them in descending. You can arrange them in 2, 2, 3, 3, 3, 7, 7. Or You can arrange them in 7, 7, 3, 3, 3, 2, 2. Anyways, any of these ways. But follow some rule. Some rule should be there. Then what will you do? If you want median, then find out the central number. Now, how many numbers are there? 1, 2, 3, 4, 5, 6, 7. Whenever you have odd numbers, then the central number is very easy, isn't it? 7 means what? So, what you have to do? 7 plus 1, 8 upon 2, fourth number. Add 1 to this and upon 2. So, fourth number 1, 2, 3, and 4. So, 3 will be the median. 3. This central 3 will be the median. Okay, this one where my arrow is moving. Okay, so whenever there is odd, it's very simple. Now, if it is even, if I am having 4 numbers 1, 2, 3, and 4, and I tell you to find out the mean, then you don't have a central number. Here you had a fourth number central. Here you don't have. So what you do, you take 2 central numbers and find out the average of them. So it is 2 and 3. So center is 2.5. So kindly remember one important exam point of view question. Kindly remember one exam point of view question. The question is, if the number of elements are odd, in that case, okay, kindly note what happens. The median is among the numbers given. If the number of elements are odd, then the median is among the numbers given. Okay. So look at this above 2, 2, 3, 3, 3, 3, 7, 7. So odd numbers were there. Your median was 3. And if the number of elements is even, then the median is not among the numbers given. So 2.5. Is 2.5 given among these? No. So median is not among the numbers given. This is a sure exam question. Okay. So kindly remember, if the number of elements are even, your median will not be among the elements given. It will be something different. Okay. So that is median. Then mode. Okay. What about mode? Mode means that number which occurs maximum number of times. Okay. Now what do you mean by this? See this. 2, 2, 3, 5, 5, 7, 8. So which number occurs maximum number of times? 2 numbers occur. 2 is occurring 2 times, 5 is occurring 5 times. 2 times. So you have 2 modes over here, 2 and 5. There are 2 modes over here. Okay, because both are occurring 5 times. Okay. So mode means which occurs maximum number of times. Got it, everyone? Clear? Okay. One more I'll take now on this. Suppose if the numbers are like this, 2, 2, 3, 5, 5, 5, and 8. Instead of 7, you have 5, let's say. 2, 2, 3, 5, 5, 5, 8. Now you tell me what will be the mode. 2, 2, 3, 5, 5, 5, 8. Now you tell me what will be the mode. Everyone. Right? Very good. So your mode will be 2, 2, 3, 5, 5, 5, 8. Your mode will be 5. Okay. Now I'll ask you one question. In this 1, 2, 3, 4, these are the numbers. What is the mode? 1, 2, 3, 4. 4 numbers are given. What is the mode? So kindly note, here there is no one maximum times. So here it means all are modes. Kindly note, all are modes. Okay. So kindly remember this. Mode can be, all of them can be modes. Okay. Then range. What is range? Range means maximum minus minimum. See this 2, 2, 3, 5, 5, 7, 8. So what is the range? Maximum is 8, minimum is 2. So 8 minus 2, 6 is the range. 6. Okay. 6 is the range. Got it? So now, kindly understand this again. Statistic versus parameter. Because although I have told you, but many of you might not have understood by now. So This is the population. Look, so many people are there. Out of them, I take some sample. So this is sample. So sampling means what? Taking from the population, and then whatever I get the answer, I'll apply it to the population. I'll apply it to the population, right? It's like drinking the tea. Suppose if you are drinking a tea, if I give you a tea, and then I ask you, is the tea hot or cold? So in that case, will you drink the whole tea to tell me whether it's hot or cold? No. You'll just take one sip, and by that you'll understand the tea is hot or cold. Same logic is over here. If I want to find out the survey of all population in Delhi or Mumbai or any city, Indore, any city, do I have to contact all the persons? No, I'll take some sample. It's like taking the sip of the tea, isn't it? So, whenever you have mean, mode, median, standard deviation, all these four elements, kindly note all these four elements, okay? If you are having it for the sample, it is called as statistic. If you are having these four for the population, it's called as parameter. Kindly note this by heart. So, suppose if I ask you median of population, so that is parameter. Median of sample, that is statistic. Okay, so you must know this by heart. Okay, this is basically this sampling distribution. Population, you take samples, find out the x1 mean, so that is basically statistic. Okay, so sampling distribution means taking the samples from the population and doing all that experiment on them. Okay, so kindly remember, now this graph I am giving you over here, because this graph you will be getting it now. We'll be solving the numericals on this. Okay, so now what do I do with this graph? Kindly note, this is the baseline, this is a central line. This central line is always known as population line. Population. Okay, this is population line. And these dots are sample dots. Kindly remember this. This is known as the population line. Hold on. Because you'll be needing it now. This is population. This is known as the population line. And these points are known as samples. Samples. All these are samples. Okay, these all samples. Okay, so you have to remember this by heart, because now when we'll be solving the numericals, you must know this. Okay, this is okay, this is not required. Now variance, technical terms. Now we are coming up to the numericals. Technical terms. Variance. Variance means what? Variance of a sampling distribution of a mean is a population variance divided by n. So, population variance divided by n, the sample size. Okay, the number of scores used to compute a mean. The larger the sample size, the smaller will be the variance of the sampling distribution of the mean. So, variance means what basically? How much is the difference? Let's understand this variance in short. See here, if this is my central line, mean line, this is my mean line. So these are my, see here, this was my population, let's say, this is my population. Okay, population mean. This is population mean. Now these are my samples. 1, 2, 3, 4. These are my samples. So whatever I am having this, the distance of this sample from the mean line, that is called as deviation. Okay, that is deviation. So deviation 1, deviation 2, deviation 3, deviation 4. Those which are above are called as plus, positive deviations. Those which are below are called as negative deviations. Okay. Then what is variance? Variance means square of this deviation. You will take the square. This distance square, this distance square, this distance square, So in variance, you will never have a negative value. Why? Because you are taking a square. Okay. So this is basically meant by this variance. Okay. So the larger the sample size, the smaller will be the variance. If I am having larger sample size, obviously my variance will be lesser. The deviations will be lesser. Standard deviation is the measure of amount of variation or dispersion of the set of values. A low standard deviation indicates the values tend to be close to the mean. So if this distance is less, It means you have taken the sample very properly. They are near the mean. If this distance is more, it means you have not taken the samples properly, right? Standard deviation is always equal to square root of variance. Remember this. Standard deviation equals to square root of variance. Okay? This already I have explained you. Standard error. Now this concept is important for you. Standard error. Standard error of a mean is the standard deviation of the sampling distribution of the mean. Okay? So standard is the standard deviation of the sampling distribution. Sampling distribution of the mean means what? The square root of the variance of the sampling distribution of the mean, that is psi upon root of n. Now one thing, I'll make it a simple logic I'll give you. What is standard error? Okay? For understanding, simple and understanding. See this, it's like this. Suppose if, what did I give you earlier? This is your baseline, this is the population line. And now if I am having the samples over here, okay? And now if I get the mean, see here, population mean is, let's say this, 20 is the population mean. And if I take the samples and the sample mean comes out to be 18, okay? Getting this? See this, I'll draw this and then show you. If this is my baseline, okay? So this is my baseline, okay? This is my population mean. Let's say the population mean is 20. This answer is 20 over here. And then I take the samples and then I find out the mean. So the, let's say the mean of this is, let's say on this side, the mean of the samples is, let's say 22. So this difference between the population mean and the sample mean, this is the standard error. This is the standard error. Kindly note this. Okay. So what do you mean by standard error? It is the difference between the actual what you have seen and the books what you have studied. Okay. This is similar to what you see in your life also. You hear that all of you might have told you, do your engineering, then your life is best. When you did your engineering, you find something else, right? You ultimately land up in the bank, as I did, right? Same thing like me only. Okay. So the logic is like this. Whatever you study in the books, kindly note the population mean line or this population line is from the secondary data. Secondary. And the sample line or the sample mean is from the primary data. Okay. So the standard deviation of the sampling distribution of the mean measures the extent to which the means vary because of the because of a chance error in the sampling process, right? Some error is there. That's why you have this difference in the sample mean and the population mean. Okay. The standard deviation of the distribution of the sample statistics is known as standard error. So standard deviation of the distribution of the sample statistics. Okay. This already. Now this bell curve, you'll see it again. Many times you'll be having this now. You're having various percentages for this. So this is known as bell curve or normal distribution curve. This is known as symmetric curve. Symmetric. See, the center is over here and it is symmetric on both the sides. So this is known as symmetric curve or bell curve, normal distribution curve. Okay. So now one thing you remember, if your population is normally distributed or not normally distributed, kindly remember this line by heart. By heart. If your population is normally distributed or not normally distributed, then also your sampling distribution will always be normally distributed. Let your population be normally distributed or not normally distributed. Your sampling distribution will always be normally distributed. Always. Okay. This question again is a compulsory question in the exam. Compulsory. Okay. So now let's solve the numericals. Okay. The sampling distribution is also normal if a population is normally distributed. The mean of sampling distribution is same as the population mean, x equals to mu, x bar equals to mu. So In this normally distributed population distribution, okay, normally distributed, which is even, your sample mean should be equal to the population mean. Okay, the standard deviation of the sampling distribution is equal to the population standard deviation divided by square root of the sample size. So this is the definition of formula of standard error. So standard error means standard deviation divided by square root of the sample size. Okay, so psi upon root of n. So kindly note, if your population is normally distributed, then your x bar will always be equal to mu. This is the formula for standard error. Now standard error has 5 formulae in your overall portion of ABM. 5 formulae, 5. Okay. One is this standard error of mean. So that is psi upon root of n. Okay. This is for infinite population. Infinite. When the population is of large size, you can't count it in the given time. Then you have finite population, which is easy to count. Okay. Means if I tell you there are 5 persons, count them in 5 minutes. It's very easy. 1, 2, 3, 4, 5. But if I give you there are 5 lakh persons, count them in 5 minutes. Not possible. So finite means which you can count in the given time. So for that the formula is psi upon root of n. See, same formula, psi upon root of n. Only you have to multiply it with root of n minus n upon n minus 1. What is n? Capital N. Population size. Small n is sample size. So n minus n upon n minus 1. Okay. So this is basically your finite population. This is the infinite population. You will get numericals on this, and we are solving this numerical now. Okay. Sampling from non-normal population. The sampling distribution of a mean approaches normality regardless of the population distribution. So what did I say? Population, be it normal or not normal, the sampling distribution will always be normal. This is what is meant. See this, it means this, if this is my population, see this is my population. It is not normal, it is something uneven. But look at the sampling distribution, it is normal. It is, see, normal curve. Okay, so this is the meaning. Okay, let your population be anything, normal or not normal. Okay, your this sampling distribution will always be normal. Okay, yeah, I'll send you a WhatsApp group also. One second. Those who have not joined, kindly join the WhatsApp group also. Okay, because I share many important PDFs and many important questions on that. Daily I am sharing it. Okay, so join that also. Okay, let me share it. Also, you should join the Telegram channel of Adda 24/7 official channel. Okay, see this, I have shared it in the pin comment. I've shared it in the pin comment. Okay, kindly join this. You should join the Telegram channel of Adda 24/7 official Telegram channel. So that also I'll share it. Okay, once again. Take this, everyone. CAIIB, no? One sec, CAIIB. This is the official channel of Adda 24/7 Telegram channel. Okay, so you definitely join this also, Telegram. Okay, and join the WhatsApp also. Okay, everyone. Let's move ahead. So now, this finite population multiplier. This finite population multiplier already I have told you, root of n minus n upon n minus 1. Okay. Now, what does this mean? When the population is not that large, which you can count, then you apply this finite population multiplier. Okay. In cases in which the population is very large in relation to the sample size of the sample, the finite population multiplier is close to 1, and its effect has less effect. Okay. So what is the accepted rule? So accepted rule is this: when the sampling fraction is less than 0.05, then the finite population multiplier need not be used. Again, exam question. When the sampling fraction is less than 0.05, now what is sampling fraction? Sampling fraction means small n upon capital N. Sample size upon population size. So if I am taking 20 samples and the population is 1000, so 20 upon 1000. Okay, so it will be what? 20 upon 1000. If you do this, what will be the answer? The answer will be 2 1 and 0.02, right? So the answer will be 0.02. In that case, it is less than 0.05. So in that case, you will not apply this finite population multiplier. Then you will consider it is infinite population. Okay. So when the sampling fraction is less than 0.05, you need not apply finite population multiplier. Very important line. Okay. Law of diminishing returns. Again, exam question. Important exam question. What is diminishing returns? Now there are 2 to 3 points which are very important from theory. Okay. Although sampling more items will decrease the standard error, the increased precision may not be worth the cost, because n in the denominator is in the denominator. When we increase it, the standard error decreases. Now what is all this? It simply means that suppose if I am taking 200 samples or to take 50 samples here, what does this mean? I am having a population of, let's say, 500. Out of them, whether to take 200 samples or 50 samples, I have to decide. Now if I decide 200 samples, then 200 samples means I'll require more persons. Suppose each sample is costing, let's say, if I want a sample, each sample is asking me for per sampling 100 rupees or 10 rupees. So per sampling 10 rupees. So 200 into 10, I'll spend how much? 2000. And if I take 50 samples, then 50 into 10, 500 I'll spend. So 500 is cheaper, 2000 is higher. But now even after doing the survey of 200, let's say I'm getting the answer of, means the answer which I'm expecting. Let's say I'm getting the answer of, let's say, 50.5 after taking the sample of 200. And after taking the sample of 50, let's say I'm getting the answer of only 50. So 50.5, or let's say, let me take a different figure. If I take a sample of 200, I'm getting the answer of 30.5. And if I take a sample of 50, I'm getting the answer as 30 only. So 30.5 and 30. What is the difference? 0.5 only. But what is the cost? Cost change is 1500, isn't it? So that is the meaning of this. If you go on increasing the samples, you will get more accurate answer. But the problem is it worth? Is it required? Because costing is increasing, isn't it? If it is not adding much value, then take 50 only, isn't it? So again, this line, sampling from non-normal distribution, again the same logic. Even if your population is not normally distributed, then also the mean of the sampling distribution is still equal to the population mean. Means the sampling distribution is again normally distributed. Okay. Remember this line. Even in case the population is not normally distributed, the mean of the sampling distribution is still equal to the population mean, because the sampling distribution is normally distributed. These questions will be there in the exam. Okay, every time they are asked. Next one, central limit theorem. Now this law of diminishing returns and central limit theorem, they are definitely asking you out of these two anyone. As the sample size increases, the sampling distribution of the mean will approach normality regardless of the shape of the population distribution. It states that sampling distribution of the mean approaches the normalcy as the sample size increases. Now this is common sense. If you go on increasing the sample size, you will get more accurate answer. Suppose if there are 1000 persons, the population is 1000, let's say. Okay. Yeah. So suppose there are 1000 persons, and out of these 1000 persons, what do I do? Suppose if I take the sample of 50, okay, or I take the sample of, let's say, 800. So obviously 800 will give me better results. So my sampling distribution will again approach normalcy as my population distribution, as my population size, sample size increases. Okay. Yeah, Himanshu, what is the problem? Link नहीं हो रहा है. Okay. What you do is, those who are having the old WhatsApp, kindly update the WhatsApp. Everyone, kindly update the WhatsApp. Okay, because WhatsApps are updated on a regular basis. You might be having the old WhatsApp. Okay, update it. So then you'll be able to join it. Okay. Use of, now look at this. Statisticians use normal distribution as an approximation of sampling distribution whenever the sample size is at least 30. So if you are taking at least 30 samples, then only you can use this central limit theorem. Otherwise you can't use. What is the use of central limit theorem? It permits us to sample statistics to make inferences about the population parameters without knowing anything about the shape and frequency of the distribution of population. So without knowing about anything about the population, you can find the answers of the population. Why? Because you are using central limit theorem. Okay. Next. One second. Hold on. Just give me 1 minute. Huh? Okay, got it everyone? Chalo. Now with this theory, let's move on to the numericals. Okay. See this. A bank calculates that the individual savings accounts are normally distributed with a mean of 2000 and a standard deviation of 600. If the bank takes a random sample of 100 accounts, what is the probability that the sample mean will lie between 1900 and 2050? Now this is problem is very easy. Okay, you need to understand the logic clearly. Sure. Firstly, what you have to do, you have to take a pen and paper. Okay, in exam take the rough paper or wherever it's possible. There are two parts in this problem. One is population, second is sample. In population, what do we do? What do we have? Look at this. The population is normally distributed with mean of 2000. So mean is 2000. So this is mu. Mu is 2000 and standard deviation of 600. So this is psi 600. Psi is 600. Okay. Now come to the sample. See, this much is population. Now what about the sample? Bank takes a random sample of 100 accounts. So n, small n equals to 100. Okay. Now next what are they asking? What is the probability? Now you are coming to the probability part. But before that, first understand the problem. Mu, psi and small n. Now first tell me, this is infinite population problem or finite population problem? How many of you can tell me just looking at the problem? Is it infinite or finite? How will you decide? Is this an infinite distribution problem, infinite sampling problem, or finite sampling problem? Tell me, everyone. Yes, on the YouTube also. Those who are watching on YouTube. It is infinite. How come finite? It's infinite. Is it given somewhere that the total number of bank accounts are 500, 600, 700, 1000? Is it given somewhere? Total number of this population or accounts is 1000, 2000. Is it given something? Nothing, isn't it? So that's why it's infinite. If they would have given that the bank has total 5000 accounts, then it would have infinite. So now it is infinite. Why is it important to know whether finite or infinite? Because the standard error depends on that. What is the formula for standard error? I told you, psi upon root of n for infinite. So psi upon root of n. Take it psi upon root of n. So what is psi? Psi is standard deviation. See this. Standard deviation was what? 600. Upon root of n. Root of n is 100. Root of 100. So 600 upon root of 100. So 600 upon 10. So 60. Okay. So your standard error becomes 60. Now once you get the standard error, kindly note. First note the standard error, because in exam they might ask you for 1 mark. The standard error only. Now after that, what you have to do is find out z. Okay, z score we call it. So what is the formula for z score? Z score is 1 upon standard error into x bar minus mu. 1 upon standard error into x bar minus mu. So what is standard error? Just now we have found out. What is x bar? X bar means basically your sample. Okay, sample mean. So where is x bar given? X bar is always what is asked. What do they require? So x bar is 1900 over here and x bar is 2050 over here. So there are two problems now. One is of 1900, second is of 2050. So that's why there will be two x bars now over here. Okay. In exam, they might ask you only one. They might not ask you this second one. They might ask you only above 1900. So first understand what is this problem. Look at this. This problem is like this. This is your baseline. This is your population mean. What is population mean given? 2000. Your standard deviation is given as 600. Now this is the secondary data. Now this is bank is knowing this. Bank has observation, secondary data. This is population data. Now bank has taken the sample of 100. This is primary data. Okay. Now the bank is finding out the mean of all these. So now when they find out the mean, they find out that in one case they are finding it 1900, in other case they are finding it 2050. So 1900 will be on the left side, 2050 will be on the right side. So if you solve this, it will be like this. See this. It will be like this. 1900 will be on the left side and 2050 will be on the right side. Okay. And this is your population mean, 2000. Now what do you require? You require this area for 2000 to 1900 and this area for 2000 to 2050. Because what is asked? What is the probability that it will lie between 1900 and 2050? Total is asked, total. So you have to find out these two areas. Okay. How to find out these two areas? First find out Z. Okay, what is the formula for Z? Just now we saw it. 1 upon standard error into x bar minus mu. So 1 upon 60 into 1900 minus 2000. 1900 minus 2000. Divide this. You'll get it 1.66 minus. Forget this minus. Ignore the sign. Sign is not required over here. So 1.66.